Hello everyone, and welcome to the first of perhaps many videos where I'll be going through computer science topics. Someone asked the other day if I'd be able to go through and make a video on the compilation process, so here we are. This will be the first of several videos on the compilation process as it's fairly complex. In this video I'm going to briefly cover the compilation process as a whole. Then, in subsequent videos, go into more detail on each stage. I'll be going through these things in detail, as it will help you get your head around what's going on. I need to stress, though, that you don't need to know the process in the amount of detail I'll be going through in these videos, and I'll therefore highlight the critical parts that you'll need to know for your exams. So, to start us off, compilation. What's it all about? Compilation. So, compilation is the process of turning source code into machine code so that it'll run on a CPU. So we've got source code into machine code. Because as we know, machine code is the only thing a CPU understands. And this process has several stages. These are lexical analysis, symbol table construction, we also have syntax analysis, semantic analysis, machine code generation, I'm just going to call that MC, generation, and finally code optimization. Okay, so there's quite a few stages in this process, but what are they all about? So, firstly, we'll start with lexical analysis. So let's go over here. So this is the first stage of compilation, and this is where we remove white space and comments from our source code. Source code, example being Python. And what we do is we turn what's left into a stream of something called tokens. Tokens. We'll be going into more depth on what tokens actually are in another video, but very quickly show you what happens in this process. Let's make a very quick bit of Python code. So I'm just going to say if num greater than 10, print greater. And what I'm going to do is, before that, I'm going to put a hash and say my code. Okay? So what lexical analysis will do here, very simply, and you'll need to know this part for your exam, is it removes comments. So it sees the hashtag and says, I don't need to know this. So basically it goes, meh, deletes it. We don't need to know that. And it also gets rid of any white space. White space, very simply, are all spaces in your program, and there's an indentation here, and it gets rid of them. So what that will then look like is if num greater than 10, print greater. Okay? Now, as I say, you don't need to know what tokens are for your exam, strictly speaking, but we'll cover that in another video. All you need to know at this point with lexical analysis is it turns your code into tokens and gets rid of any white space or comments from your code. So what I've done is I've turned this into this. Okay? Now, we move on to symbol table construction. Okay, so once we've got our stream of tokens, what we do is we turn it into a symbol table where we match all of those tokens with keywords in the language, and we turn all those variables into tokens as well. What I mean by a keyword is anything that is defined within the language. So what I can say is, looking at this code here, I can say if, that is a keyword, the if keyword, greater than is a keyword, print is a keyword, and these are language specific. Now if you look at this code, we can see num. Num is not a keyword, num is actually a variable, and 10 is a number. And there is a way a computer knows how it's a number, but we won't go into that. But what we do is we call anything that stands for itself a literal. Okay, so examples of literals are 10, the word greater, and various other things. Anything that doesn't perform a particular function. So, in summary, what we do is we take our token stream, turn it into keywords, such as if, greater than, print, and we also turn it into keywords such as var, and we also make sure we store the names and the addresses of all our variables, constants, and arrays. I'm going to go through that again in another video, but all you need to know is for symbol table construction, we create a table where we match up all of our statements with keywords. So in this case, num, we know num is a var, and it's located at address, whatever address that is. After symbol table construction, what we then do is move on to syntax analysis. Once we've matched our tokens, we pass these tokens to the syntax analyzer, and its job is to make sure that the tokens are in a logical order so that they follow the grammar of a language. So, as an analogy, we can understand what Yoda says, but a computer can't do that. It has no idea what Yoda will be talking about. So what we need to do is we need to make sure that anything anyone says is in the right order that a language understands, and that's the language grammar. So we pass in these tokens, it makes sure they're in the right order and that it makes sense. Once we've done that, we move on to semantic analysis. And semantic analysis is very simply, we check all the variable types to make sure they're correctly declared and that the meaning of the code makes sense. As an example, a dog is a rug makes grammatical sense. You know, it makes complete sense. However, it does not make semantic sense. We know that a dog is not a rug. In the same way, the semantic analyzer takes what you've written and checks to make sure it makes logical sense. Okay, so very similar to a dog and a rug. Once it has made sense, and once it's convinced that your program makes sense, we move on to the actual machine code generation. Now, we'll go into machine code generation, how it actually works, in another video. But all it does is it turns your code into binary. Okay? We do this using the compiler to turn it from your Python, for example, into assembly language, and from assembly language we use something called the assembler, and the assembler turns it into binary for us. Now, you'd think at this stage that we're done, and for the most part we are done. However, there's one more thing we can do with our code. Now that it's in machine code, what we have to do is, depending on what device you're programming, you need to make sure your code is optimized. Not all devices work the same way, and not all devices have the same memory or CPU, for example. So what we do is we say, okay, I'm looking at my code, and is this the most efficient it can be? Maybe, maybe not. We look for patterns in our code, patterns, and we also look for ways to get rid of things we don't need. Now, the compiler handles this itself completely. You don't need to worry about it when you're programming. But once it's done, what we eventually get is an .exe file. And you can just run this file over and over as many times as you want. And that is the whole compilation process in a nutshell. And it's quite a long process. But again, this is the important information. This is what you'll need to know for your exams. As I said earlier, I'll go through each process in more detail, but you don't need to know it in that much detail. The detail that I'll go through only exists to make sure that the process is clearer in your mind. Okay, and if you want to know more, just check out those videos as they become available. If not, just look at this, look at the resources online, look at your textbook, look at your work booklets, anything you can find, particularly BBC Bite Size as an example, and it'll walk you through the basics that you would need to know for your exam. So, that is our first video on the compilation process. I hope that was helpful. If you've got any questions at all, just let me know, and we can answer any of those questions in further videos. So, thank you very much for watching, and I'll see you soon.